Hey guys, today we're going to talk about multi-charge metals. So it turns out that there are some ions, some elements that can form more than one different type of ion. So for example, a bunch of transition metals, like for example iron, can form iron 2 plus or iron 3 plus. And we won't get into the reasons why it does that, but just the fact that it does that makes identifying a compound with iron in it a little bit more tricky, because if we're talking about iron 3 oxide, that's a different chemical formula than iron 2 oxide. So we'll talk about how we get the name iron 3 or iron 2 oxide, and how we can tell kind of what the formula is and what the name is based on how we name it. But before we do that, here's a little review. Go ahead and try this out. First four questions are kind of asking you about name to formula, formula to name. So at this point, my hope is that you've paused the video and that you're ready to go with these four. Great, here we go. Beryllium oxide is BeO. They both have a charge of 2 plus, so that's why it's 1 and 1. Lithium nitride, I have 3 lithiums because nitrogen is 3 minus, lithium's 1 plus, so Li3N. This here, Na is sodium, and sulfur would be sulfide, so sodium sulfide. Al is aluminum, and Cl is chlorine, so aluminum chloride would be the name for the second one. How many electrons does chlorine have? It's got 18. When it's a minus, that means 18, because it's the negative 1, we add 1. So normally it has 17, plus the negative 1 gives us a total of 18. How many protons does chlorine have? Chlorine just normally has 17 protons. That's also true when it's an ion. Hopefully everything here seems reviewed at this point. If not, go back and watch one of the previous videos, please. Okay, we're going to talk about multi-charge metals. Can we name them, and can we write the formulas? So here's what we've done already. We did binary, which is we know the charge of the nonmetal and we know the charge of the metal. We know the charge of our nonmetal, which is usually our cation, and we know the charge of the metal, which is usually our anion. Here with multi-charge, we will know the charge of the nonmetal, just like before. However, we will not know the charge of the metal. When I say we won't know the charge, we'll have a multiple choice question, pretty much, and we'll have to pick between 2 or 3 different options. Sometimes more, sometimes 4 or 5, just kind of depending on what ion you're dealing with. So these metals we'll see have more than one possible charge, so we won't know which charge is correct until we actually do the problem. If you were to answer the question, what is beryllium oxide versus what is iron oxide, you're going to get different answers. Here's our ion list. This is on the back of the periodic table. I referenced it yesterday. So we'll see in column 5 of positively charged ions, beryllium's up here, and it's got a 2 plus charge. That's the only charge. However, if you look at iron in column 20 or in row 22, iron can have a 2 plus or it could have a 3 plus charge, if you see down here. So what that means is iron can form a couple different compounds. So if we're just saying iron, that's not really specific enough. We'll have to say something like iron and then put a little Roman numeral 2 there, or iron and put a Roman numeral 3 there. And that'll tell us, hey, this iron we're dealing with has an oxidation state of 2 plus, has a charge of 2 plus. Or this iron here has a charge of 3 plus because it's got a Roman numeral 3 next to it. In case you were wondering what Roman numerals were, here are the Roman numerals. So 1 is I, 2 is 2I, 3 is 3 slashes, 4 is a slash and a V, 5 is just a V, 6 is a V and a slash, and 7 is a V and 2 slashes. So 4 slashes will not work for 4. We want slash and then V, just because that's how it's supposed to be. Okay, so naming binary compounds, this is stuff you should have some practice with. WF5 will be tungsten, V in parentheses, fluoride. In this case, tungsten can have more than one possible ion, so we're going to put a V there. That V stands for a charge of 5 plus, because if we actually break this up, we know fluorine has a charge of 1 minus, and we know that there are 5 of them. So in order for one tungsten to balance out 5 negative charges, our tungsten has to have a charge of positive 5. Hopefully that makes sense how I found out that tungsten has a charge of positive 5. I'm just kind of looking at the nonmetal and figuring out what its total charge is, and then kind of figuring out the other ion. Zinc in this case would just be zinc iodide. If you look at zinc on the periodic table, it'll say Zn2 plus, and that'll be it. Zinc has no other oxidation states, so we don't have to put a Roman numeral 2 here because there's only one possible charge for zinc, and that's 2 plus. It doesn't also have like a 3 plus or a 4 plus or a 5 plus, if that makes sense. Cobalt has more than one charge here. This one's a little bit tricky. So you'll see that we have two nitrogens. If you look on the periodic table, you'll see that each nitrogen has a charge of 3 minus. So we've got two 3 minuses. That gets our total negative charge to be 6 if we kind of add all of them up. So then our total positive charge has to be positive 6. And we got that from 3 cobalts. So that means each cobalt has a charge of 2 plus. So it would be 2, and then 4, and then 6. That's kind of how we get cobalt's charge in that case. For those of you wondering, is there an easier way other than looking back at the periodic table every single time? No, there really isn't. So you can always check if your metal is multi-charge, and if it is, then you want to write down the metal non-metal name. Or sorry, let me re-explain this. So these are rules for formula to name when you're dealing with a multi-charge metal. The first thing you have to do is you have to flip over to the back in that ion list and check if the metal is multi-charged. That's the most important step right there. If it's not, then you don't have to do anything. You just write the name of the metal, write the name of the non-metal, change the metal ending to IDE. The situations we're talking about today are when, yes, it is multi-charge. When that happens, you've already found the metal's charge. So what you just do is you take that, let's say it's a 2 plus, and then you put it next to the name of the metal in parentheses. So you'd put 2 Roman numeral 2 in parentheses right next to the metal's name. So it's just one extra step now, is that if the metal has more than one charge, you have to write down what that charge is in Roman numerals right next to the metal's name. So you'd write iron and then Roman numeral 2, or iron and then Roman numeral 3, something like that. These are the 3 rules that you do every time, and now we're just saying watch out for multi-charges. Okay, so I think this is a little bit easier, writing from formulas given a name. So gold 3, we know our gold is Au3+. And then bromide, we know is Br, and we can look on the periodic table and figure out that, hey, it's got a charge of 1 minus. So then the question becomes, how do we get these to cancel out? We're going to need +3 and -3. So to do that, we're going to need 3 bromines, and we'll get a final answer of AuBr3. Hopefully this makes sense how to go from name to formula. Go ahead and try these next 2. Great, pause the video because you need more time. Here we go. Platinum has a 4 next to it. So PT is going to have a 4 plus, and oxide is oxygen, just O, and it's got a 2 minus. So in this case, I'm going to need 2 minuses to cancel out my 1 platinum, and that's going to give me a formula of PTO2, and that 2 just goes for the oxygen. Last one is bismuth phosphide. For this one, bismuth has a charge of 5 because we got that V there, and phosphorus just normally has a charge of 3 minus. So for this one, I'm going to need 3 bismuths and 5 phosphoruses. That way the total adds up to 15 for the positive side and 15 for the negative side as well. Hopefully this makes sense how I'm getting the numbers. I'm just kind of taking this number and multiplying it by the charge and then making sure the charges are both positive and negative and that they're equal on both sides is kind of the goal. So that hasn't really changed. What will change then is going from a formula to a name. Now we have to include these Roman numerals when we're dealing with a metal like gold or platinum or bismuth, a metal that could have more than one different charge. Gold could also be a 1 here. If it was a 1, then our formula wouldn't be AuBr3, it would just be AuBr, because I've got a charge of 1 plus for gold and 1 minus for bromine. Platinum could also be 2 plus, so in this case it would just be PTO, not PTO2. Bismuth could also be 3 plus, so instead of being Bi3P5, it would just be BIP. So again, these multi-charges, it's very, very important to write down the Roman numerals. So, rules for forming the name, find the charge of the metal. This step is super easy because we give you the charge of the metal. When it's a multi-charge, we tell you right in the Roman numeral. So this step is super, super easy. Find the charge of the non-metal. You're going to have to look at the ion list. You're going to have to look at that negative column. And then make sure the net charge is 0. These are the same rules as single charge metals here, folks. So hopefully this feels good. So there kind of has to be an easier way. One of the things I did is I went ahead and went through the periodic table and marked down every element that doesn't form an ion. Just kind of get rid of all these guys here. You'll notice I left the atomic numbers so you could see them. That way you can kind of like, oh, hey, that's carbon there, and that's silicon over there. You can kind of look and see where these things, so none of the noble gases form ions, for example. Yeah, that sort of thing. So hopefully you can kind of see which elements I'm talking about here. The red numbers here, or I guess these are now green numbers, these are fixed charges. So everything in column 1 will always be 1 plus, everything in column 2 will always be 2 plus. Columns 13, 14, 15, 16, and 17 get a little bit more tricky because some of them follow these rules, but some of them don't. Some of these guys down here have multiple charges. Outlined in red, we have all the metals, the transition metals that have multiple charges. So all these guys have multiple charges. Anytime you see one of these guys, you're going to want to look on the back of your periodic table. Here are a bunch of ions that have just a single charge, and they're transition metals with a single charge. So all these 3 pluses here, the 4 plus, the 7 plus, the 1 plus, and the 2 plus over here. And then lastly, we have these guys over here, which are multi-charge metals that are not transition metals. So you can always look at the ion list, but in case you don't want to, in case you just want to copy this down on your periodic table, just as a little quick check so you don't have to flip it over all the time, you can write these numbers in discreetly in a place where you can still see the other information on your periodic table. Maybe that's helpful for you. Or maybe it's not. It's really up to you. Okay, so here's the binary ionic beryllium oxide. It's just Be2 plus and O2 minus, so it'd just be BeO. With iron oxide, if we were to give you that name, iron oxide, we wouldn't necessarily know what numbers to put here and here. So we have to write in a Roman numeral here in the middle in iron oxide. Oh man, this is kind of messed up. Okay, well, what I'm going to do here is I'm just going to kind of let you guys go. The moral of the story here, though, is Fe and O versus Fe2O3. You could get 2 different formulas if your charge is a 2 plus or a 3 plus. So you've got to look at the ion list and think, okay, which one are we talking about here? Or you got to look at the formula and think, okay, what does the Roman numeral tell me? So hopefully that helps. I hope you guys have a great rest of your day, and I hope this comes a little bit easier for you guys. Thank you so much. Have a great rest of your day.